Professor Nalox Quibble adjusted his 7 ocular enhancers as he gazed out at his class of final-year students. His purple tentacles twitched with anticipation. This particular cohort at the Galactic Institute of Applied Sciences was, by far, the most promising he'd seen in his 342 cycles of teaching advanced hydrological engineering. Attention, students. Professor Quibble's voice resonated through his vocal amplifier. Today marks the beginning of your final assessment project, one that will separate the merely competent from the truly exceptional among you. The classroom bubbled with nervous energy. 23 of the galaxy's brightest young minds from 17 different species sat before him, each representing the pinnacle of their homeworld's educational system. As you are all painfully aware, Quibble continued, pacing across the hover platform at the front of the amphitheater, our beautiful campus planet of Aquanus 7 faces a rather embarrassing problem. Our primary ocean, which once served as the pride of the Galactic Institute, has become a toxic, polluted mess thanks to centuries of careless waste disposal and experimental runoff. He activated the holographic display, revealing a murky, oil-slicked body of water that stretched across 30% of the planet's surface. Several students recoiled at the sight, while others took furious notes. Your challenge is this: design and implement a water filtration system capable of effectively cleaning a designated section of the Aquanus 7 ocean. You have precisely 1 standard week to complete this task. Blorp, a gelatinous being from the methane swamps of Velis Prime, raised a pseudopod. His translucent body rippled with excitement. Professor, what parameters will you use to evaluate our success? Excellent question, Blorp. Your grade will be determined by 3 factors: efficiency of design, volume of water purified, and sustainability of your system. Professor Quibble's mouth tentacles formed what passed for a smile in his species. Theoretically, a perfect score would require cleaning the entire ocean, though of course, that's utterly impossible given the time constraints. Nervous laughter rippled through the class. Everyone knew the ocean contained roughly 30 trillion gallons of water. In the back row, Ziktar clicked her mandibles thoughtfully. The insectoid's compound eyes glittered as she already began calculating potential solutions. Beside her, Krell, a silicon-based life form from a high-gravity world, remained perfectly still, his crystalline body absorbing every word. And then there was Jake Harrington. The only human in the class sat slouched in his seat, absently doodling on his datapad. Professor Quibble sighed inwardly. The human exchange program was still new, and while humans had a curious reputation across the galaxy, this particular specimen seemed perpetually disinterested. His academic performance was adequate but uninspired. You may work individually, or in groups of up to 4, Quibble announced. Submit your preliminary designs by tomorrow's class for initial feedback. Remember, this project constitutes 60% of your final grade. As students began buzzing excitedly, forming alliances and debating approaches, Professor Quibble couldn't help but notice Jake Harrington's reaction, or rather, lack thereof. The human simply nodded, closed his datapad, and wandered out of the classroom while the others frantically discussed complex filtration technologies. That one, Professor Quibble muttered to himself, is either completely hopeless or dangerously overconfident. Little did he know, both assessments would prove spectacularly wrong. By the following morning, the laboratory complex buzzed with frantic activity. Holographic schematics floated above workstations, complex equations covered every available surface, and the air crackled with the energy of competition. Our approach must utilize quantum harmonics, announced Blorp, whose gelatinous form now contained tiny bubbles of excitement. He had assembled a team with Turok, a 4-armed mammalian mathematician, Phyla, an energy-based entity, and Dreeg, a collective consciousness inhabiting a robotic shell. The crystal resonance purifiers will create vibrational frequencies that cause molecular separation of contaminants. Their workstation quickly became covered with glowing crystalline structures that hummed at frequencies just beyond comfortable hearing range. Whenever the team activated their prototype, nearby liquids separated into distinct layers of fantastic colors. Impressive, commented Professor Quibble during his rounds, but how will you scale this to oceanic volumes? "We're developing amplification chambers," Turok replied, all four hands busily manipulating holographic blueprints. "Theoretically, we can purify up to 7 million gallons per day." Professor Quibble nodded approvingly, though his mental calculation confirmed this would clean less than 0.00003% of the ocean in the allotted time. Still, it was elegant work. Across the lab, Ziktar had assembled her own team. The insectoid's mandibles clicked rapidly as she directed her partners in constructing what appeared to be a microscopic fabrication unit. Nanobots, guessed Professor Quibble as he observed their work. Yes, Professor Ziktar's compound eyes glittered with pride. Self-replicating nanobots programmed to identify and consume specific pollutant molecules, then convert them into inert compounds that will sink to the ocean floor. "And what prevents your nanobots from consuming the entire ocean and everything in it?" asked the professor, raising an eyebrow stalk. "Triple redundant failsafes and a limited replication cycle," answered Ziktar's teammate, a plasma-based entity named Vorex. "The nanobots will self-destruct after completing their programmed consumption quotient." Professor Quibble made a note on his datapad. Creative and potentially dangerous, exactly what he expected from Ziktar's brilliant, but sometimes reckless approach. The silicon-based Krell had formed perhaps the most technically sophisticated team. Their workstation glowed with pulsing gravitational fields that bent light and caused small objects to float and separate. "Gravitational separation fields," Krell explained in his rumbling voice that sounded like grinding stones. "We can create localized gravity wells calibrated to the exact molecular weight of specific pollutants. The contaminants will be pulled into collection chambers while leaving clean water behind." "Fascinating approach," noted Professor Quibble. "Energy requirements." "Substantial," admitted Krell. "But we're developing a zero-point energy tap to compensate." The professor's eye stalks widened. Ambitious. As impressive as these projects were, Professor Quibble couldn't help but worry about Jake Harrington. The human had claimed a small corner workstation where he sat alone, surrounded by crude sketches on actual paper and archaic medium that puzzled the alien students. No holographic projections, no complex machinery, not even a basic molecular separator. "Mr. Harrington," Professor Quibble ventured, approaching the human's workspace. "The preliminary design submission deadline is in 3 hours. May I inquire about your progress?" Jake looked up, flashing what humans called a smile of facial expression that still unnerved many non-terrestrial species. "Just working through some ideas, Professor. Trying to keep it simple." Professor Quibble glanced at Jake's sketches. They appeared to be rudimentary filtration systems, pipes, and what looked like containers filled with bacteria. Several of the designs were crossed out, replaced with even simpler configurations. "Simple." Ziktar clicked mockingly from across the room. "Is that what humans call doing nothing? The ocean isn't going to clean itself with stick figures." Several students chittered, buzzed, or gurgled with laughter. Jake shrugged good-naturedly. "Sometimes the simplest solution is the most effective." "Mr. Harrington," Professor Quibble said quietly, "while I appreciate philosophical approaches, this project requires actual technological implementation. Are you certain you wish to continue working alone?" "Absolutely," Professor Jake replied, returning to his sketches. "Trust me, I've got this." Professor Quibble retreated to his office, concerned. He pulled up Jake's academic file, reviewing the notes from the Galactic exchange program. Humans had a curious reputation in the greater community, technologically primitive by galactic standards, yet occasionally brilliant in unexpected ways. Their so-called lateral thinking was well documented, if poorly understood. Meanwhile, back in his corner, Jake finished his final sketch, nodded to himself, and established a quantum communication link to Earth. His conversation was brief but specific, involving requisition numbers, coordinates, and delivery schedules. When he finished, he submitted his preliminary design, a single page with a surprisingly straightforward system diagrammed in crisp, clean lines. The equipment Jake ordered would arrive within 16 hours, transported via the Galactic Institute's matter transfer network. He closed his notebook, stretched, and walked out of the lab whistling a tune no alien could recognize, an ancient Earth melody called Whistle While You Work. 3 days into the project, the laboratory had transformed into a carnival of scientific achievement. Professor Quibble had designated this day for prototype demonstrations, and the air hummed with anticipation, and the distinctive odor of academic anxiety, a scent remarkably consistent across all sentient species. "Attention, everyone," Professor Quibble announced, his voice amplifier cranked to maximum to be heard over the whirring, humming, and occasional alarming explosions from the various prototypes. "We will now commence with preliminary testing. Each team will demonstrate their filtration system using the standardized sample of ocean water provided." Each team had received identical 10-gallon tanks of the polluted Aquanis 7 ocean water, complete with oil slicks, heavy metals, chemical runoff, and the particularly problematic forever molecules from centuries of industrial waste. Blorp's team went first. Their crystalline array pulsed with hypnotic light as they carefully positioned it above their sample tank. "Observe the harmonic separation process," Blorp bubbled excitedly, activating the device. The crystals began to vibrate, emitting tones that made several students' sensory organs ache. The polluted water in the tank rippled, then gradually began separating into distinct layers of different colored contaminants. After approximately 20 minutes, about 2 gallons of clear water had been extracted from the sample. "Remarkable efficiency on a small scale," Professor Quibble noted, examining the purified water with a molecular scanner. 99.3% contaminant removal. However, the energy consumption is concerning. He glanced at the power readout, which showed the small demonstration had consumed energy equivalent to powering a small city for a day. Blorp's outer membrane flushed with embarrassment. "We're still optimizing the energy matrix, Professor." Next came Ziktar's nanobot demonstration. Her team released a vial of microscopic robots into their sample tank, where they immediately began to swarm like a silver cloud. "The nanobots are identifying, targeting, and consuming specific contaminant molecules," Ziktar explained, her mandibles clicking with pride as she projected a microscopic view onto the main screen. The image showed tiny machines latching onto pollutant molecules and breaking them down. 5 minutes later, the water was noticeably clearer, but then alarms began blaring. "Replication rate exceeding parameters," shouted Vorex, Ziktar's teammate. "Emergency shutdown initiated." The team scrambled to deactivate the nanobots, which had begun multiplying at an exponential rate. After a tense minute, they succeeded in neutralizing the swarm. "Effective, but potentially catastrophic," Professor Quibble commented dryly. "I'd rather not turn our ocean into a self-replicating machine apocalypse. Thank you." Krell's gravitational separation field proved the most visually impressive. Their device created localized distortions in space-time itself, causing pollutants to swirl away from clean water, as if by magic. The contaminants collected in floating globules that could be easily removed. "Most elegant solution thus far," Professor Quibble admitted. "Though I note your device has created several small tears in the fabric of reality," he pointed to the shimmering rifts that had appeared around the laboratory. "Perhaps not ideal for planetary deployment." Krell's crystalline form vibrated with what might have been embarrassment. "Minor calibration issue, Professor." As the demonstrations continued, Professor Quibble realized something was amiss. "Where is Mr. Harrington?" he asked, scanning the laboratory. "The human?" snorted Ziktar. "Probably still drawing stick figures somewhere." Perhaps he realized his primitive understanding of hydrological engineering was insufficient and withdrew from the project, suggested Turok, earning chitters of laughter. Professor Quibble frowned. Regardless of Mr. Harrington's capabilities, he is still enrolled in this course and responsible for meeting deadlines. "Computer, locate student Jake Harrington." The Institute's AI responded promptly. "Student Harrington, Jake. Current location, Dormitory Complex B, room 427. With a concerned flick of his tentacles, Professor Quibble assigned the remaining demonstrations to his teaching assistant and made his way to the human's quarters. When he arrived, the room's biometric scanner recognized his faculty credentials and allowed entry. "Mr. Harrington?" he called, stepping inside. The room was empty. Well, not entirely empty. The walls were covered with paper, an astonishing waste of organic material by Galactic standards, filled with calculations, diagrams, and notes scrawled in the odd angular script humans called handwriting. Several empty containers of a substance labeled coffee littered the desk, along with food packaging that emitted an aroma Professor Quibble's olfactory sensors classified as distressingly pungent. One note, larger than the others and stuck to the center of the main wall, caught the professor's attention. System deployed at coordinates 47.892, minus 126.345. Ocean Access Point Alpha. Professor Quibble's ocular enhancers widened in surprise. That location was at the northwestern edge of the campus ocean, a practical testing site, but hardly suitable for a class demonstration. "Computer," Professor Quibble demanded, "when did student Harrington last leave this room?" Student Harrington, Jake, exited dormitory complex B approximately 26 hours ago. 26 hours? The human had been gone for more than a full day. Professor Quibble rushed back to the laboratory, interrupting Dreeg's demonstration of a particularly unstable molecular destabilizer. "Change of plans," he announced. "We're taking a field trip. Everyone to the transport bay immediately." "But Professor," protested Blorp, "we haven't finished the demonstrations." "Demonstrations are meaningless if a student has potentially endangered himself with an unauthorized ocean deployment," Professor Quibble replied sharply. "Besides, I believe we're about to witness either a spectacular failure or something else entirely." As the class hurried toward the transport bay, whispers and theories circulated. "I bet the human just went swimming and forgot about the project," Ziktar clicked to her teammates. "Or perhaps he fled due to inadequacy," suggested Krell. Professor Quibble remained silent, his mind racing. The coordinates Jake had left pointed to a remote cove, one rarely visited by Institute personnel. What could the human possibly be doing there, alone, for more than a day? He was about to find out. The Institute's transport shuttle hummed as it skimmed over the landscape of Aquanis 7, carrying Professor Quibble and his bewildered students toward the mysterious coordinates. Through the viewport, the polluted ocean stretched out below them, a vast expanse of murky, chemical-laced water that had long been the planet's greatest shame. "I still don't understand why we're wasting valuable development time on this wild excursion," complained Ziktar, her mandibles clicking irritably. The human clearly abandoned the project. "Perhaps he drowned," suggested Blorp, his gelatinous form jiggling with what might have been concern or amusement. "I understand humans are surprisingly fragile in liquid environments." Professor Quibble silenced them with a wave of his tentacles. "We will withhold judgment until we assess the situation directly." The shuttle's navigation system chimed. "Destination approaching," announced the pilot, a multi-limbed being who manipulated the controls with practiced precision. As they crested a final ridge, a collective gasp rippled through the cabin. Even Professor Quibble's respiratory tract constricted in shock. Before them, stretching across nearly a mile of shoreline, was a massive industrial operation unlike anything they had expected. Enormous pipes extended from the shore into the ocean. Massive floating platforms dotted the water's surface, connected by a network of smaller tubes. Most shocking of all was the visible boundary in the water itself, a stark line where murky pollution met crystal clear blue. "What in the name of the 7 quantum realms is that?" exclaimed Turok, all 4 of his hands pressed against the viewport. The shuttle landed on a designated pad near what appeared to be a control center, a simple prefabricated structure with earth markings. As the door hissed open, Jake Harrington emerged, waving cheerfully. His clothing was stained with grease and seawater, his hair disheveled, but his expression was one of unmistakable satisfaction. "Hey, Professor. Everyone, welcome to the cleanup operation. You're just in time for the midpoint status report, Jake called out as they disembarked. Professor Quibble approached cautiously, his scientific curiosity overriding his administrative concerns. Mr. Harrington, explain yourself immediately. What exactly have you done here? Jake gestured expansively. I cleaned the ocean, Professor. Well, about half of it so far. Impossible, snapped Krell, his silicon form vibrating with indignation. The volume of water is too vast for any individual system to process in such a limited time frame. Jake grinned. Not if you use the right system at the right scale. Come on, I'll show you. He led the stunned group into the control center, where wall-mounted screens displayed real-time data of the operation. One massive display showed a satellite view of the ocean with a clear demarcation between processed and unprocessed water. A progress meter in the corner read 47.3% complete. This is unprecedented, murmured Professor Quibble, his tentacles twitching with academic excitement despite himself. How is this possible? Jake pointed to a schematic on the main screen. It's actually pretty simple. I'm using a combination of 4 Earth technologies that have been around for centuries, just modified and scaled appropriately. He tapped different sections of the display. First, we have basic mechanical filtration using graduated mesh systems to remove large particulates and debris. Nothing fancy there, basically the same principle as a coffee filter, just enormous. A what filter? Asked Phyla. The energy. Not important, Jake waved dismissively. The second component is bacterial remediation. I've deployed genetically engineered bacteria that consume specific pollutants and break them down into harmless compounds. They're self-limiting once they run out of food. They die off naturally. Ziktar's compound eyes narrowed, similar to our nanobots, but biological. Exactly. Jake nodded enthusiastically. Third, we have acoustic disruptors that use specific sound frequencies to break down complex molecular chains that wouldn't be caught by the filters or consumed by the bacteria. Blorp bubbled thoughtfully, reminiscent of our crystal resonance approach. And finally, Jake continued, we have centrifugal oil separators that spin out petroleum-based pollutants for collection and removal. The whole system is modular and self-replicating. Each clean water module produces the components needed for the next module, so the operation scales exponentially. Professor Quibble circled the control room, examining the readouts with increasing astonishment. But the energy requirements for such an operation must be astronomical. Jake shook his head. That's the beauty of it, Professor. The entire system is powered by the ocean itself, a combination of wave action, thermal differentials, and chemical energy harvested from the pollutants. It's actually generating excess energy, which accelerates the expansion process. But this is primitive technology, sputtered Krell. There are no quantum fields, no molecular restructuring, no gravity manipulation. Primitive doesn't mean ineffective, Jake replied with a shrug. Sometimes the old solutions are the best ones, especially when properly scaled and integrated. Professor Quibble's scientific mind was racing. Mr. Harrington, are you suggesting that all of this, he gestured at the massive operation visible through the windows, is based on technology that existed on Earth 2 centuries ago? Well, with some modifications, Jake admitted. The bacterial strains are modern, and the acoustic frequency modulators use some newer principles. But yeah, the basic approach is straight out of Earth's environmental cleanup playbook from the 2100s. But how did you deploy all of this so quickly? Asked Vorex, the plasma entity. The resources required. That's the real innovation, Jake said, leading them to a side room where a single, unassuming machine hummed quietly. This is a fabricator unit. I designed it to produce all the components needed for the cleanup system using materials extracted from the ocean itself. The pollutants become raw materials for more cleanup equipment. He pulled up another display showing the expansion rate. The first module took 12 hours to build and deploy. The second took 6 hours. The fourth took 3. By now we're deploying a new module approximately every 7 minutes. By tomorrow morning, the entire ocean will be clean. The alien students stared in disbelief, their various sensory organs struggling to process what they were witnessing. But this defies all conventional approaches to hydrological remediation, protested Blorp. That's because you're thinking like galactic engineers, Jake explained patiently. Humans had to solve these exact problems with limited resources and primitive technology. We couldn't rely on exotic physics or advanced energy manipulation. We had to be creative. Professor Quibble found himself oddly moved by the elegance of the solution. Mr. Harrington, in all my centuries of teaching, I have never witnessed such a brilliant application of fundamental principles. You've achieved in days what the most advanced systems on our campus have failed to accomplish in decades. Jake smiled, scratching his head somewhat bashfully. Thanks, Professor. To be honest, I wasn't sure it would work at this scale. Earth's oceans were much bigger, but also took years to clean. I just figured the principles would translate if properly adapted to local conditions. As the implications sank in, the alien students began approaching the various displays, their previous mockery replaced by genuine curiosity and, in some cases, unmistakable awe. Could you explain the bacterial selection process? Asked Ziktar, her scientific interest overcoming her pride. How does the acoustic modulation prevent membrane damage to native aquatic life? Inquired Krell. Professor Quibble watched as Jake patiently answered each question, explaining the surprisingly simple principles behind what would ultimately be one of the most successful environmental engineering projects in the Institute's history. Sometimes the professor reflected, the most profound solutions were hidden in plain sight, disguised as simplicity. Professor Quibble arrived at the shoreline precisely at dawn, his sleep cycle having been thoroughly disrupted by what he had witnessed the previous day. He had spent most of the night reviewing Jake's schematics, but trying to comprehend how such a seemingly simple system could accomplish what the Institute's finest minds had deemed impossible for decades. To his surprise, he wasn't alone. Nearly all of his students had returned as well, their various forms of transportation dotting the shoreline. Even more surprising were the dozen or so faculty members from other departments who had heard rumors of the remarkable human project. Is it true? Demanded Professor Zarn, the head of theoretical applications. Has the human actually purified a significant portion of the ocean using primitive Earth technology? Professor Quibble's mouth tentacles curled in what might have been a smile. See for yourself. The assembled group gazed out over the water. Where yesterday there had been a clear boundary between clean and polluted sections, now there was only crystal blue water stretching to the horizon. The contrast with the historic pollution was so stark that several faculty members activated their auxiliary visual processors, convinced they were experiencing sensory malfunction. Impossible, whispered Professor Zarn, a sentiment echoed by several others. Jake emerged from the control center, looking exhausted but triumphant. Dark circles rimmed his eyes, and his clothing suggested he hadn't changed in days, but his smile was genuine. Good morning, everyone. Right on time for the completion ceremony. Mr. Harrington, Professor Quibble said, his voice amplifier barely hiding his excitement. Am I to understand that the entire ocean has been processed? Jake nodded, suppressing a yawn. Completed about 40 minutes ago. The final module came online at peak efficiency, and the last section processed faster than our projections. Here, I'll show you. He led the growing crowd back into the control center, where the main display now showed 100% complete in pulsing green letters. Below it, a real-time analysis of water quality showed readings that seemed impossibly perfect. This must be a malfunction, declared Professor Yorick from the Marine Sciences Division. These readings suggest the water is actually cleaner than the natural state of most oceanic bodies in the galaxy. That's because it is, Jake replied. The system doesn't just remove pollutants, it actively enhances water quality by introducing beneficial minerals and optimizing oxygen content. Professor Yorick immediately dispatched several drones to collect samples from different parts of the ocean. When the results came back minutes later, the control room fell into stunned silence. "The human speaks the truth," Yorick admitted, their bioluminescent appendages glowing with excitement. "The ocean is not merely clean, it's ideal for aquatic life forms across multiple taxonomic categories." Professor Quibble turned to Jake. "Mr. Harrington, while the achievement itself is worthy of academic recognition at the highest levels, I must ask, how did you conceive of this approach when our most brilliant minds have failed for generations?" Jake ran a hand through his disheveled hair, considering the question. "Well, Professor, humans had to clean up their own mess the hard way. Earth's oceans were devastated by centuries of industrial pollution, plastics, chemical runoff, you name it. We nearly destroyed our planet's aquatic ecosystems entirely." He gestured toward the schematics on the wall. "These systems aren't theoretical for us. They were developed out of desperate necessity, refined through decades of trial and error. We couldn't rely on fancy quantum tech or gravity manipulation, we had to work with what we had." "But the scale," protested Krell, whose crystalline form had been vibrating with scientific curiosity since arrival. "Even accounting for basic principles, the logistics of cleaning an entire ocean in days rather than centuries should be mathematically impossible." "That's where the real innovation comes in," Jake explained, bringing up a new display. "The system is modular and self-replicating, but it's also adaptive. Each module learns from the performance of previous modules and makes micro-adjustments for greater efficiency. It's a simple feedback loop, but at this scale, even tiny improvements compound exponentially." Blorp, who had been unusually quiet, finally spoke up. "But what happens now? Will the system be dismantled?" Jake shook his head. "That's the best part. The system is now transitioning to maintenance mode. Those platforms you see out there," he pointed through the window to the structures dotting the ocean's surface, "will remain in place permanently, monitoring water quality and activating only if pollutants are detected. They're self-sustaining, powered by wave action and solar energy. This ocean will never be polluted again." "Remarkable," murmured Professor Quibble. "A solution that addresses not only the immediate problem but prevents its recurrence." The alien students gathered around the displays, their previous competitiveness forgotten in the face of genuine scientific wonder. Ziktar was examining the bacterial components with her compound eyes, while Krell studied the acoustic modulation patterns. Blorp had somehow managed to obtain a sample of the filtration medium and was running his own tests in a corner. "I don't understand," said Turok, all four hands gesturing in confusion. "If humans possessed this technology centuries ago, why isn't your species dominant throughout the galaxy? With environmental engineering this advanced, you could terraform worlds with ease." Jake laughed, though the sound held a hint of sadness, "because we almost destroyed ourselves before we figured it out. These technologies came after we'd already pushed our planet to the brink. Sometimes you have to make the biggest mistakes before you find the best solutions." As the implications of Jake's achievement spread throughout the Institute, the mood among the alien students shifted from disbelief to a complex mixture of humility and fascination. They had arrived at the Galactic Institute believing themselves to be at the pinnacle of scientific understanding, only to be shown that sometimes true innovation lies not in the most complex approach, but in the most elegant application of fundamental principles. And somewhere in the depths of the newly cleansed ocean, native life was already beginning to flourish once more. 1 week after the ocean of Aquana 7 had been transformed from a toxic waste dump into a thriving aquatic paradise, the amphitheater of the Galactic Institute of Applied Sciences was filled to capacity. Students, faculty, and even representatives from the Galactic Council itself had gathered for what was being called the Harrington Assessment. Professor Nalox Quibble stood at the podium, his 7 ocular enhancers gleaming with excitement. Behind him, holographic displays showed before and after images of the ocean, along with real-time metrics of the flourishing ecosystem. In my 342 cycles of teaching, Professor Quibble began, his voice amplifier set to maximum to reach the back rows. I have evaluated thousands of students across 17 species. I have witnessed brilliant theoretical frameworks, revolutionary technological innovations, and paradigm-shifting discoveries. His tentacles gestured expressively toward Jake, who sat somewhat uncomfortably in the front row. But never, in all those cycles, have I witnessed anything like what Mr. Jake Harrington has accomplished. The professor activated a holographic projection of Jake's grade assessment. A glowing perfect score rotated slowly above the audience, eliciting a wave of murmurs. Mr. Harrington not only fulfilled the theoretical impossible criteria for a perfect score by cleaning the entire ocean, but did so in a manner that has fundamentally changed our understanding of environmental remediation technology. Professor Quibble then made an announcement that sent ripples of shock through the assembly. It is therefore my honor to offer Mr. Harrington a permanent research position at the Institute, heading a new department focused on practical applications of fundamental technologies. The audience erupted in applause, a cacophony of tentacles slapping, mandible clicking, crystalline resonating, and various other species-specific expressions of approval. Jake stood and made his way to the podium, looking both honored and slightly embarrassed by the attention. When the noise finally died down, he cleared his throat. Thank you, Professor Quibble, and thank you all for this incredible honor. But I think there's been a misunderstanding about what I actually accomplished. He tapped the podium controls, bringing up schematics of his system. What I did wasn't genius or revolutionary by human standards. On Earth, we call this appropriate technology, solutions that use locally available resources and fundamental principles rather than cutting-edge science. Jake smiled ruefully. The truth is, humans learned to think this way because we had to. We nearly destroyed our own planet through short-sighted applications of advanced technology. We poisoned our oceans, polluted our atmosphere, and pushed countless species to extinction before we finally learned our lesson. His expression grew more serious. Human ingenuity doesn't come from inherent brilliance. It comes from centuries of catastrophic mistakes and the desperate need to fix them. We've had to become experts at cleaning up our own messes. To everyone's surprise, Ziktar stood up from her seat. On behalf of the student body, I request permission to form a study group under Mr. Harrington's guidance. We wish to learn this human practical thinking approach. One by one, other students rose: Blorp, Krell, Turok, Vorex, Phyla, Dreeg, and dozens more, until nearly the entire student section was standing. Jake blinked in surprise. I would be honored to work with all of you. 6 months later, the impact of Jake's innovation had spread throughout the Galactic Institute and beyond. The curriculum for every engineering course now included what had been officially designated as the Harrington Principles. 1. Simplicity over complexity when possible. 2. Use what's available before creating something new. 3. Scale proven technologies before inventing unproven ones. 4. Design for sustainability from the beginning. 5. Learn from natural systems rather than replacing them. Planetary governments and corporate entities from across the galaxy began sending representatives to study these principles, as worlds that had been deemed beyond salvation due to environmental catastrophe suddenly had hope for recovery. 10 years after what became known as the ocean incident, Professor Quibble, now the Dean of Environmental Sciences, stood before yet another class of first-year students, representing 23 species from 34 different worlds. Before we begin our formal studies, he said, his tentacles now slightly grayer but still animated with enthusiasm, I want to tell you the story that changed the direction of applied sciences throughout the galaxy. It begins with a seemingly impossible challenge and a single human who approached it differently than anyone else. The students leaned forward, eyes, stalks, sensory membranes, and various other perceptual organs focused intently on the professor. "This is the legend of the human who cleaned an ocean in a day," Professor Quibble began, "and how sometimes the simplest solution is the most profound." Outside the classroom windows, the pristine waters of Aquana 7 sparkled in the sunlight, teeming with life that had been absent for centuries. And across its surface, almost invisible unless you knew where to look, Jake Harrington's simple yet revolutionary modules continued their silent, efficient work, a testament to the idea that the most powerful technology isn't always the most complex, but the most appropriately applied.